Hey, welcome back to the 8th episode of the Decomposition Pattern podcast, where we break down the hardest stakes in tech and programming into their fundamental components, separate signal from noise, tackle complex topics with clarity, and rebuild our understanding from the ground up. This is Jose, and today we're going to talk a little bit about exceptions and hidden control flows. I've been thinking a lot about this, not recently, but for a long time now. Um, and I think we need to think a little bit more of how we're going to handle how are we handling errors in languages that obviously implement constructs of exception and hidden control flows. So there are 3 points that I want to talk about and I want to pass to you, which are first, let's go define these concepts. What are exception, what are control flows, and what is the deal with hidden control. Second is, well, what is this? What is the problem? What is my beef with exception? And then finally, we're gonna talk about how to avoid problems that I'm gonna talk about, exceptions and actually predictable software out of that. So let's just start by definitions, right? So what are exceptions? Exceptions, by the definition of the word, are things that don't follow the rule, are like exceptions to the rule, are deviants of the rule. And what are control flows? So the control flows are the order of execution in imperative languages mainly, but they are the order of execution of a software. So all these, I'm going to line 1, 2, 3, and then I go into function calling, and then I enter in that function, and then I exit. All of that is a control flow, right? So there's an order of execution of statements and functions. So what is the problem here? So what is the problem of using exceptions? The problem that I found in my experience with using exceptions is the existence of hidden control flows by consequence. So whenever a language has these implementations of exceptions, they usually also have a way of handling those exceptions, right? And generally what that means is that they will have the capacity to hijack how the program executes. So if let's go to a practical example. So if I'm going to call a method and I send something that it's not expected to receive, the method might throw an exception, type error, type mismatch, or some rule, the thing that I send misses some rule that is required to kind of evaluate to true, and it doesn't, and then the method throws an exception, like this is not supposed to happen, you need to send me something valid. So that is an implicit decision right there. So whoever coded that method decided that if that thing happens, it is to end the execution of the program. But sometimes the context of the caller might not align with that implicit decision. Right? Maybe it's not supposed to end the program. Maybe there's a way to recover out of that exception. And the way that we have to do it is by using the so-called try-catch blocks. Right? So try to execute these. It is defined or known that the method might throw this exception, and if that happens, I'm going to catch it and not let it bubble up to end my program, but I'm going to catch it. I'm going to try to do some recovery or continue on with my flow, right? So that is what is called a hidden control flow. And why it's hidden when it's like somebody's programming for that? It's hidden because whoever calls that caller, right, might not be aware that happens. So, and there might be side effects that happen without an explicit understanding of what happens. So the software might go into control flows, right? Might have that order completely changed. Let's say that we are expecting by working with a repository of products, we are expecting it to return the list of most recent updated products. But for some reason, I just don't send something that is not a problem for whoever I am calling, but whoever I called, the method that I call, will call another thing, and it might have a bug that violates the rules of that other thing, and it throws an exception, and then the exception is kind of caught, right? And then it kind of might throw an event, or might write to the database, or might send an email to all developers saying something weird happens. This is a stupid example, but just a way to show that having these constructs and these ways of handling exceptions might make the software go into paths that are hidden, right? That might not even be totally known by whoever calls it. Might even be in a different system or whatever. But and all steers from that implicit decision of throwing an exception. Generally, if we move aside from the technical concepts that we talked about here, why are these exceptions? Most of the times they are just validating integrities, right? So they are just making sure that business rules are applied, that invariants did not deviate from what is expected, but it's not necessarily something unexpected. It's something that might happen. I don't know when, but we know that it might happen, and we can't continue to work. That's for sure. Our execution flow inside of that trace can't continue. We need to stop the execution. But does that mean that we need to decide to stop the entire application? Not necessarily, but we can't just return an empty thing in a way that we can just stop execution right there and return to the caller without any information about what happened. So what's left? Well, what I've been growing as a real fan is return results. What do I mean with that? Instead of deciding to throw an exception, I might return a validation error. Hey, I was expecting this ID to be valid, but I can't find it, so it's not valid for me. What do you want to do? And that's basically what the systems, right? So the callee turned to the caller and said, I can't find this, I can do this, I can continue. So I'm just returning to you saying, I can't do it. Here's what I know that this does not exist. What the hell do you want to do? And the caller decides. And that aligns much and makes the software much more predictable, and it unlocks other ways of doing error management instead of doing exception handling. Okay, this means that, hey, if the result, the caller then can decide, okay, if the result is not a success result, I consider a success, then I'm gonna try with a different identifier. Maybe I just didn't use, maybe there are two identifiers for some reason, or maybe I just want to return something completely different. But the core concept here is that I'm not hijacking the execution flow with those try-catch blocks, and don't even get me talking about the finally blocks, right? So I have a major background in PHP, so I'm used to see those try, catch, and finally, and those are a mix of confusion, and they can be a real pain in the ass to debug, right? Because the catch itself is to catch exception, and we can even go into the basic type of a throwable of an exception, and that pretty much catch everything that can be thrown. But then we have the finally, which will ensure that the software continues executing, right? So we can even do even more things besides what happens in the catch, because the execution flow will be forced to go back after the entire catch and the entire chain of calls that might happen in that catch block is executed, and it will return, and then it continues executing through there. I've seen crazy things being happening due to this construct, and that's my beef with all of these exception use. I think that exceptions should be for things outside of our control. Like, I am communicating with an outside service and it's not responding. I might throw an exception. Or I might even be completely sane and continue to return results. Like, I couldn't connect with this system. What do you want to do? The caller might even put me on an infinite loop, like continue to try until you can do it. But another kind of stupid basic example, right? But something that the point is the caller should decide. Whoever asked me to do something, I should only do my job. I should not decide by others. Can you imagine if you were to be asked something by a colleague or the boss or whatever, and you just doing implicit decisions that might not even line up with the vision or whatever the caller need the person that talked to you to do something or asked to do something? Like, can you imagine the problem there, right? So I think that's a little bit what happens when we use exceptions and try to handle those exceptions by using these hidden control flows, exception handling. So that's by returning the results, we move away from these possible problems and we make our software be a little more predictable. We give back control of the flow to whoever called upon that method or function, right? You let them decide. We just do, we can even fit this in that single responsibility box, right? So I'm not responsible for deciding the entire software to go down. I'm just responsible to say that I cannot continue to work. Here's what happened. You decide whatever is good for you in terms of handling this possibility, right? So yeah, that's basically pretty much what I wanted to talk about, these exceptions. So the next time you're going to create any validations, checks for integrity, whatever that you think you're going to need to throw an exception, think again. Maybe what you need is to return a failed response or something, or a failed result status, and that would help you, or you'd be helpful for the caller, and the caller then can decide, can match on that failure status and can decide or to do something or to do nothing, right? So, but the point is, it's not up to you to decide, right? If it needs to really escape the execution or terminate the execution, it can just go into the terminate routines and just do the cleanup and whatever, instead of failing hard. Okay. So yeah, that's it for today's episode. Again, call to action: come to our discord.thedecompositionpattern.com. Come join us, come talk about your experience. What do you think? Have you seen this pattern being used, the returning a result instead of throwing exceptions? What are your thoughts about it? Come discuss, come interact, and let's exchange ideas, right? So until that, till the next episode, have a nice day.